Okay, we want to recap today on our mole conversions and then extend that idea into what's called reaction stoichiometry. So, we learned in our last unit that Avogadro's number, 6.02 times 10^23 particles, is how much is in 1 mole. 1 mole is how much a molar mass of something weighs. We were calling it also formula weight. It's the weight of the formula. And so that's also really called the molar mass, but that leads to molar volume if we're dealing with a gas at STP. And so we've had those numbers and we've been using them in our flow chart. We gave you a picture for the flow chart. We've learned how to convert numbers. So like an example, let's say we have hydrogen gas and we have 16 grams of that gas. And we wanted to know, well, how many moles is that? And so we've learned, and we taught you in the chart, you just simply need to use these as an equality, and we know we can use them. We know that the molar mass is equal to 1 mole, and 1 mole has 6.02 times 10 to the 23rd particles, and we can use any name like atoms, molecules, ions, that kind of stuff. And we also know that 1 volume of any gas, if it's at STP, is 22.4 liters of space it will take up. And so we had those conversion brackets. So if I was actually concerned about turning your grams into moles, we just said that we had 4 steps. Number 1, write down your given number. So we're starting off with 16 grams. We asked how many moles is that? From mass to moles is 1 jump. So in 1 jump, we put 1 bracket next to it. And so we're going from mass to moles. What goes on top is the second thing. So we want moles, so we're going to flip our thing over here, our bracket, and we're going to put 1 mole on top, and we're going to put the molar mass of hydrogen on the bottom. Well, hydrogen in our periodic table over here weighs 1, and so 1 times 2 is 2 grams. If it's set up correctly, our grams should cancel. So then 16 divided by 2 is 8. Moles is the only unit left over, so that's our unit. So the answer is 8 moles. And that's how we did conversions. If I wanted to go and turn this into volume, all we have to actually do really easily is change the number of jumps. And to go from moles to volume, we would just simply add another jump. And if we go up to volume, we want a volume, the one we want goes on top. So we put 22.4 on top over 1 mole. And we would just take the 8 times 22.4 and we solve that problem. No problem. So really simple. We just count the number of brackets, we fill our brackets in, and we do those number of jumps, and we make sure that the names that we don't want cancel out. So that's a quick recap of the chart we did, okay? Called mole conversion. Okay, we like to complicate things a little bit, but really it's not complicated. We know that oxygen and hydrogen do react together. And so let's take our 16 grams of hydrogen we had earlier. And we know that when they react, they actually do make water. We did this in a reaction in this lab, our labs earlier this year. But the problem is, to do this, each element or compound you work with has to have its own flow chart. So how do we do it? How do we go and ask you a question about another material, maybe when you want to ask you about grams? How do we do that with this flow chart or stoichiometry? Well, it's really simple. We need a flow chart for each material. So I'm going to draw another flow chart, but I'm going to mirror it another direction. So instead of being in this direction, I'm going to push the mass over here. So these are volume boxes. These are mole boxes. These are particle boxes. And these are mass boxes. Okay? And what we've discovered with this flow chart, the reason why we taught it to you this way, is that now we can expand the kind of problems that we can ask you. So our new question is, if I've got 16 grams of hydrogen, how many grams of oxygen would I need to react with it? Just like if you're cooking, you need so much flour, and you need so much baking soda, and you need so much chocolate chips and whatever to make the correct formula for your chocolate chip cookies. So we need so much oxygen. Well, all I need to do is get from this mass box to this mass box. And how do I do that? Well, I have to jump the chart. And jumping the chart is very simple. You need the balancing coefficients. So what we need is we need to find the coefficients from this balanced equation. And so whenever you're being asked about two materials, they have to be in a chemical equation. I just can't jump from hydrogen to gold or hydrogen to carbon if they're not in a chemical equation. So these questions and these bigger charts only work for things in the same equation, but it's not balanced. If I want to balance it, I need to actually have 2 oxygens over here, which means I have to have 4 over here now, and so that's now a balanced equation. And here's how you do it. It's very simple. We found the exact same steps as we did before. You write down your given number. We said we have 16 grams of hydrogen, and our question was, how many grams of oxygen are we going to need? So we're going to go back to our chart. We write down our given number. There it is. We then go back to our charts and we identify one chart for hydrogen and one chart for oxygen. It doesn't matter what chart is which. I'm just going to always put this one on the left to be the one farther over in my equation. So this is my hydrogen chart. I'm starting in the hydrogen chart in its mass box, grams. I want to make it all the way to the gram box in the oxygen chart. So there's my unknown. My chart shows me I need 3 jumps. So we said after you write down your number and you count the number of jumps, you make that many brackets. So we have our brackets. There are 3 jumps. Now we just follow the thing. How do we fill them? The one you want goes on top. I want to go from mass to mole. So I want to take this jump, put mole on the top. And then it says I need to put the formula weight or the molar mass on the bottom. Whose chart am I in? I'm not in the oxygen chart. I'm in the hydrogen chart. 2 times 1 is 2 grams. So that's the weight of the hydrogen, forgive me. And then we want to now jump from mole to mole. Mole to mole, or particle to particle, or bond to bond, doesn't matter where you jump, you use what's called the mole ratio, or the coefficients. The one you want goes on top. I want to go to oxygen's chart. So the number or coefficient in front of oxygen is nothing is there, so that means there's a 1. The one I come from, its coefficient, goes on the bottom. So this is called a mole ratio because you're pretty much going from mole to mole. Okay? We'll practice that some more. So then I want to make the last jump. If we go to moles to mass, we know it's got to use the moles in the formula mass. So I want to go to formula mass. So I'm going to put the molar mass on top, but now I'm in the oxygen chart. So I have to use 2 times 16, which is 32. And I put 1 mole on the bottom. If we've done it correct, like we've talked about before, all our units should cancel out. Grams cancel out, moles cancel out, and moles cancel out here. I'll get a gram answer. And so 16 divided by 2 is 8. 8 divided by 2 more is 4. Then 4 times 32 is 128 grams. So that means that to use up 16 grams of hydrogen, we would need 128 grams of oxygen. So that's how much is needed to use up the 16 grams. Okay?